2015 is where they're ending this, and essentially they're saying that the amount of materials that's going through and the attention we're giving it through recycling is insufficient. And we know this intuitively, but we're still kind of stuck on that whole thinking that we're going to be able to solve it through better recycling, better infrastructure, better collection, better, more. But it's not coming out. When you start looking at the amounts, this is the quantity that this paper estimated, that 12 million metric tons of plastic will end up in some form in the environment, whether it's buried or released into natural environments by 2050. That's a significant quantity. And here, they're only concerned with looking at macro stuff, so things that are in the form of stuff, written products. We also see that this was a recent paper that came out actually earlier this year, and this study was looking at one particular plastic, PET, polyethylene terephthalate, which is used in water bottles and soda bottles and things like that. And it's ubiquitous. It's also in, no one's wearing a fleece, but generally fleece is also PET material or polypropylene. And this is sort of, it tracks the flow of PET in the US using the 2015 data. But really, it's deceptive because what you see is a whole lot of green stuff and some other blue stuff, denoting that there's end markets for this material. And then there's this pile of red that's disposed. When you actually look at the numbers and redraw this chart, essentially this is the traditional recycling marketplace. And I'm not throwing stones at recycling, I'm just saying it's insufficient as a framework of material stewardship. And when we look at it in aggregate, this is the amount that's being discarded. This is the amount that has potential secondary uses, not necessarily actual secondary uses. It's collected for secondary uses. So sometimes the data themselves, the way they're visualized, gives us a misperception that we're doing a way better job than we actually are, collectively or regionally and individually. In our program that I'm part of, materials management, we talk in terms of systems or life cycle flows. And we also know this intuitively. Everything comes out of this one animated or cartoon planet. We process things, we make things, we transport them, we sell them, we use them, we discard them. And that microplastics and macroplastics are sort of coming from all directions. They're not just coming from our homes, they're not just coming from our businesses or end-of-life management. They're coming in throughout the network. And microplastics is even worse in that sense because we can't even see that stuff. It's showing up in our water supply, it's showing up in our food products. And so this is part of the work that I'm involved here in the Pacific Northwest, trying to figure out what's that mapping, what does it look like, what are the hotspots for the substances that we're looking at in the micro stage. And we don't even know what polymers we're looking for. So I'll have a slide where we're starting to get a picture of what kind of polymers are more prevalent than others. So in terms of flow here, what we're talking about is that this is the ecosystem of microplastics. That it's coming from urban environments, so that's our setting where we are. But it's also coming significantly from agricultural applications. So plastics are used for cover. Plastics are also used to disseminate pesticides and herbicides in nodules that are sort of time released. That time release is essentially breaking that molecule or that container to release the compound. So that plastic remains. Eventually it runs off in the soil. It's incorporated in the soil or runs off through rain. It also shows up in our wild spaces because, as we'll see, transport is occurring through the production cycle, so industrial and agricultural. Transport is occurring through use phase, us and businesses. It's also happening through disposal. One study in Taiwan or in Vietnam has clearly shown that recycling itself is contributing microplastics into the water supplies. So this is a study that we're proposing to do in Oregon to see to what extent our own systems that we're considering virtuous, which is in the process of being renovated. We have the legislation, the Recycling Modernization Act, and Plastic Pollution Prevention. So to what extent does our own system contribute to this pollution, this level that we can't see anymore? And then lastly, Earth system itself. So there's flows of microplastics and fibers happening through air and through water cycles. So we are starting to understand more how these substances are moving. We don't know yet what the outcomes are, the endpoints, as Kevin mentioned. We don't know what the effects are, and that's still an unknown space. But the ubiquity aspect is really true. So a recent, this is a composite chart, so this is not one study. This is looking at all the research in the last 7 or 10 years to see what are the different kinds of polymers that are showing up in the media. course, because it's the solid waste. This slide was used to talk to solid waste folks. But essentially, everything that shows up in the materials management in the solid waste management theme shows up. So PVC, urethane, polystyrene, polypropylene, polylactic acid, which is PLA, that's the bio-based stuff, EVA, PET, and then polyethylene, the other stuff, polyamide, latex, and so forth. But they're showing up in some studies. They're actually being able to show effects on applied features, fish and others. So they're just practicing, or not practicing. They're demonstrating what the effects might be and trying to see what certain kinds of exposures are leading to. So again, this is also the preliminary stuff, but we're starting to see the whole spectrum of materials showing up into in the micro and nano stages. So I'm just gonna I'm running through it fast because we want to have some Q&A. But this chart, this map of Oregon shows a study recently done over the last few years, and it's an ongoing study where we're adding more data to it. This is to sample waterways in Oregon and see to what extent or what kind of polymers are showing up. And anyone want to guess how many of the samples actually had polymers in it? 100%, yes. And 100% of the sediment samples are collected in the riparian zone as well. So it's not a matter of it might be out there. We know it's out there. Again, not to be gloom and doom, but just you got to start thinking differently about these substances. We know now that there's evidence of microfibers and microplastics moving in the air. We know its effects on it's coming out of washing machines. So there's one study in proposal. We're seeking grant funding to do a study of efficacy for putting filters on washing machines to see to what extent can we curb it before it even goes into the wastewater stream. We've talked about sediments, but now more and more studies are starting to document things like microplastics showing up not just in our blood and fetuses. It's been shown in human placenta 2 years ago, and now it's showing up in the dairy and meat itself, not just on the surface, but inside the meat itself, in the tissue. So this is scary stuff. And our current frameworks don't allow us to get to this level of comprehension, not even just understand it first before we can start policy or management techniques. Part of the problem is that when these substances go to 100 microns and below, the so-called nano and anything below that, we don't have measurement techniques, we don't have collection techniques. Our equipments are not up to snuff. And we certainly don't have analytic techniques. Our own lab at PEQ doesn't have the equipment. So all of this stuff is evolving, but we're still sort of really far behind in terms of dealing with existing systems that say, can we put a pause on production of plastics, for example, before we can, so give us time to contain some of this issue. Like PFAS, if you're dealing with, or Kevin even mentioned that if we're dealing with one compound at a time, that assumes that the marketplace isn't introducing anything new. And even if it didn't introduce anything new, it would take decades for us to deal with that. So there's some conundrums in how we're framing these kinds of concepts. When we bring it down into drinking water, and this ties back to both Kevin and Al's conversation, this was a 2017 composite study. 94% of tap water in the US that was sampled for plastic fibers. So this was not all plastics, it was just fibers from clothing and things like that. 94% of our drinking water that comes out of tap has fibers. So chances are we're all drinking sometimes. Anyway, so that's just a kind of slide. Okay, so connecting back to Al and to Kevin's conversation, you know, in this space alone, 10,000 known additives are present. So phthalates are one aspect of it. There's also all sorts of other soups and concoctions that are coming into the process. There's 2,400 known substances of concern, 53% unregulated, and 11% had no scientific reference. If you searched it in different literature, you don't find anything. You don't find it in databases of chemicals. So that's scary stuff. So I want to just run through one slide. This is just as a context setting. It's not meant to be anything other than just context setting. So when we speak of environment, this is a question talk from at a university I gave, but this is relevant because oftentimes we talk about the environment, saving the environment, protecting the environment. But what is it that we're talking about, generally speaking? So I just want to walk through that. That at the Earth system level, this is the living planet. This is where we are part of. We have scientific understanding of water flows. We have scientific understanding of air currents and flows. We have soil and geologic understanding. But at the end of it, when we start to actually deal with media measures and processes and quality indices, the environment, what we're talking about is boiling all of this complexity down to very simple stuff: water, air, land. And within that, we've developed measures. So in case of water, it might be DOD, a process might be TMDL, and that composite gives us an air quality or water quality index. And so if we follow that logic, most laws are made around environmental protection in this box. It doesn't separate outside. And outside is where living biota lives. Outside is where people and their places interact with the systems. They're not part of the construct. So the things that both Al and Kevin talked about in terms of ubiquity and where it shows up in our clothes and things that we don't even know. Dental floss has PFAS. Wow. And there's no way of finding out which dental floss has PFAS. So it's an awesome problem. And I just throw this out there to say that what we talk about in terms of environment is much smaller than what it really is. So what our tools are capable of today needs to evolve in a way such that we can understand and reflect and project whatever that vision of the future is, whether it's 2050 or 2030. Getting there is not the same train that got us here. We're going to have to imagine different ways of contemplating and formulating these things so that we construct regulations, we construct design structures, we construct ways of selling and buying things. Like we just came out of the safer choice discussion where the question in my mind was, why is it that Dow, that has maybe 99% of its material or chemical portfolio, doesn't have to go through the green chemistry certification, but the one tiny guy with a 25-year employee has to go through that to prove that his is greener, everything else is coming out as grandfather. So I think we need to question what it is that we're trying to protect and how it is that we're trying to protect. That's just the message. So sorry for